Our strategy for encoding an object as a function works when there's only one operation that we care about. So if the only thing we do with the shape is get its area, then we can have it be a function that returns a number, and calling that function is the same as getting the area. But what if we want to ask the shape for different kinds of results, maybe an area or maybe a perimeter? One approach is to take this idea very literally of asking the object to do something and change the function so that it starts out with a symbol that says what operation you want. So that when you have a rectangle function, you call it with the symbol area to get the rectangle's area, or you call it with the symbol perimeter to get the perimeter. And so the way that we would implement a shape using this type is we would have a rectangle constructor that gives us back a shape as a function, but now instead of 0 arguments, the function takes a symbol operation. And if that operation is area, then we return the area. If it's perimeter, then we return the perimeter. And we can implement another shape, square, with the same operations, just different implementations of those operations. Taking a look at this in Dr. Racket, here's that same code, which I can run it. We get 150 for the area, 35 for the perimeter. I can make a square of size 10, and if I just make the square, when I hit enter here, then I will get a function back. But if I say square 10 and then ask it for its area by calling it with the area symbol, then I will get 100 back for a square. So we can do more with this encoding of objects, where we can have different symbols corresponding to different operations. But there's another trick here, which is that area and perimeter both take 0 arguments and return an integer. And that's why they both fit into this kind of type. We just select one of them and always get an integer back. What if we wanted to have an operation, a scale operation that works here? We need to get the amount to scale it by, and we need to return a shape, not an integer. To handle this more general pattern, instead of having a single function, which takes a simple argument, we can have a list of functions each paired with a symbol. So the area function, say, could be a function that takes no arguments and returns integer, while the isBiggerThan function will take an integer that you want to compare it to and returns a Boolean instead of an integer as its result. I'm having to use the untyped version of Shplait because what we're doing now no longer fits into Splait's type system. For this kind of encoding, it's going to be helpful to have a find function that takes a list of tuples, each keyed by a symbol, and a name symbol that you're looking for, and gives you back the value that's associated with that symbol. So it's a straightforward recursive function searching through a list. We will use that to find and call methods on our objects. So now the rectangle constructor, instead of returning a single function, it returns a list of tuples. One of those tuples is tagged with area, another is tagged with isBiggerThan. Square has the same 2 tags, and now when we call rectangle, it's because we take the rectangle, find its area method, call that with 0 arguments, and we can get the area back. Or we look inside of R to find isBiggerThan, which will give us this function here. That function expects an extra argument, 100, and we compare whether the area of this rectangle is bigger than 100, which it is. Calling a method like this works, but it is a little tedious to always use find and then a quoted name, and then more in parentheses for the arguments. We can clean this up by introducing a macro for dot that calls the find function for us with the quoted identifier and then passes the arguments along. So using this dot macro, then I can call the area method on R just with r.area, or I can call isBiggerThan as r.isBiggerThan.